Okay, so this is a review of Chapter 8. Our first question, which ordered pair is a solution of 2x minus 4y equals 6? So when it's a solution, that means the xy pair would solve the equation correctly. It would be true when we plugged in x and y. So if we plug in 10 for x and 10 for y, what would we get? Well, here we would have 2 times 10 minus 4 times 10, because again, 10 was our x and 10 was our y, equals 6. Is this true? 20 minus 40 is negative 20, and that does not equal 6. So this one is not true. Our next one, we have 8 and 4, so we plug in 8 for x and 4 for y. We have 2 times 8 minus 4 times 4. Is that equal to 6? So 2 times 8 is 16, minus 4 times 4, which is 16, so that's 0. That does not equal 6. That one doesn't work. The next one, 2 times negative 1 minus 4 times negative 2. Is that equal to 6? Well, 2 times negative 1 is negative 2. Negative 4 times negative 2 is a positive 8. Is that equal to 6? 8 minus 2? That is equal to 6, so this one works. When you're doing multiple choice, you might as well try the last one if you have enough time. So on a standardized test, if you find the right solution, I would circle it, and then you can go back and check it if you have enough time. On a test where you have unlimited time, just go ahead and do it right now. So 2 times negative 3 minus 4 times negative 4, is that equal to 6? We have a negative 6 right here and a positive 16. So that's going to give us a positive 10. That is not equal to 6. So it doesn't work, so we have one solution. In which quadrant is the graph of negative 2, negative 5? So this is just a point. If we remember our coordinate grid, this is quadrant 1. And then we go counterclockwise because the people doing this were just silly. So we go counterclockwise. So this is quadrant 1, this is 2, this is 3, this is 4. If you notice, in quadrant 1, we would always have positive and positive. Positive x values, positive y values. In quadrant 2, we're going to have negative x values, but positive y values. In quadrant 3, everything's negative. We go backwards for the x, we go down for the y. And then in quadrant 4, we're back to positive x's, but negative y's. So this one is a negative 2, negative 5. We would go negative 2, we go left 2, and then down 5. So that's going to be in quadrant 3, where both are negative. Where is the graph of 0, 4 in the coordinate plane? Okay, so let's do that in a different color. 0, 4. 0 means we go out nothing, but we go up 4. Are we in a certain quadrant? We're not. We're on an axis. Which axis are we on? This is the y-axis, remember? And so this is the x. So we are on the y-axis. Find the slope of a line that passes through 2, 1, and 3, negative 6. We could draw it. If you wanted, you could get a good graph paper and you could plot where 2, 1 is and where 3, negative 6 is. And then you can find the stepping distance between them. We could also remember that our slope is our rise over our run. And when we have 2 points like this, we just need to find what's the rise. Well, that's the difference in their y's, right? Because rise is up and down and the y values go up and down. So the difference in their y's, I'm just going to take the first one and subtract the second one. Difference is subtraction. So 1 minus a negative 6. That's my difference in my y values. or the change in my y values. Run is the back and forth, and those are our x values. So I need to start with the same one I started with. I started with the 1, so I need to start with this x value, the 2, and I'm going to subtract this x value, which is 3. Now I just have to do 1 minus a negative 6, so that's really 1 plus 6, so 7. And then down here, 2 minus 3 is a negative 1. Now I don't have to leave this as a fraction. That negative can go anywhere in the fraction and still be correct. So if I move it to the top, I have negative 7 over 1, or just negative 7. That is my slope, also labeled as m. Find the slope and y-intercept of the line whose equation is y equals 4x, y plus 4x equals 8. So on this one, most of the time we're used to getting this form of a line, y equals mx plus b, where m is our slope and b is our y-intercept. So we just need to rearrange this just a little bit. Y doesn't have any coefficients, so that's good. We just need to move this x to the other side so that it's in this form. If you don't, you'll see that there's going to be a difference in what you think the slope is. So let's rearrange it. We're going to subtract the 4x to the other side. So over here, we get 0. We are left with y equals, and then I have an 8 and a negative 4x, so I'm going to put the negative 4x plus 8. So now it's in the form that we're used to. Here's our m right in front of our x, and then our b is this number right here. So our slope is our m, which is now negative 4 because we had to move it over to get it in the right form. If you had pulled it from the original equation, you would have said positive 4, and that would not be correct. So make sure that it's in the slope-intercept form if you want to pull that number straight out of the equation. Our y-intercept is our b, so that's 8. And that's all we have to do. Find the equation of a line with a slope of negative 2 that passes through 8, negative 4. Find the equation of a line with a slope of negative 2 that passes through 8, negative 4. So we know we're starting with y equals mx plus b. And we have the slope, so that's our m. We can put that in right here. But we still have 3 variables. We have a y, an x, and a b. Well, we need the m and the b to define the line. We usually leave the y and the x in there. But in this case, we have a point. That is our x and our y. So I can plug in negative 4 for y, and then I can plug in my 8 for my x. Now I only have one variable, that's b, and that's what I need to help me define the equation. I'm just going to solve for b. I have negative 2 times 8, which is negative 16. If I move that over here, it's a positive 16. So 16 minus 4 is going to be 12 is what b is equal to. So now I just put that back into y equals mx plus b. b is my 12, m was my negative 2, and this is how we write the equation of a line. It has a y and it has an x in it because our equation of the line can be any point on the line, so any point would have an x, y coordinate. Now we're writing the equation of a line given just 2 points. Well, we knew how to find the slope from 2 points, and then our last one was knowing the slope in one of the points. So what we're going to do is start with finding our slope. Remember, that's our rise over our run, and our rise is our y's. So I'll just start with this one. My y value is 6, my other one is 2. I'm going to do 6 minus 2. Then my next one, my x's are 4 and 1. So I start with 4 minus 1. 6 minus 2 is 4. 4 minus 1 is 3. So my slope is 4, 3. But I still don't know what my y-intercept is. So I am going to plug in either point. It doesn't matter. This one looks a little simpler with 1s and 2s. So I'm going to choose that one. It may not be, but we'll use it anyway. Okay, so 2 goes here for my y. 4/3 times x, which is 1, plus b. So I'm solving for b. Here I have 4/3 times 1. That's just 4/3. So I'm going to subtract that over. So 2 minus 4/3 is what b is equal to. I have some fractions, so I need to convert this one so that I'm doing like fractions. 2 is the same thing as 6/3. So 6/3 minus 4/3 is equal to b, and 6 minus 4 is 2 over 3, so b is 2/3. The last thing I do is go back and rewrite it as a y equals my m, which we already knew is 4/3 x, plus b, which is 2/3. Okay, now we're drawing a graph. The best way to do the graph is from the y equals mx plus b. So you can just pull out the y-intercept and pull out the slope. This is not quite in that form. So I need to get y by itself on one side of the equation. To do that, I'm just going to move over my 3x. So I'm going to subtract my 3x to both sides. That way I have it as y equals negative 3x plus 6. So then to graph it, my y-intercept means where it intersects the y-axis at 6. So there's a point right here at 0, 6. This is my y-intercept because 0 means it will be on the y-axis. I'm not going back and forth in the x direction. And then I go up 6 in the y direction. Now my slope is negative 3. Remember that slope is rise over run. If I think about negative 3 being over 1, that helps me just count it out. So I'm going up a negative 3, which means I'm really going to go down 3. 1, 2, 3, and over 1. Now you only need 2 points. If you have a very straight edge, you can connect those. If you want, you could count one more point. So down 1, 2, 3, and over 1. And that just helps you to line things up. So you want to draw your line with a straight edge, and you want to keep going past the points that you already have. The line goes infinitely in both directions. So don't just draw between the 2 points. Draw the entire line. Our next question is, what value is the domain and what is the range? Domain is our x values, also going to be our input values. Our range is our y values, and when we get to problems, it will be our output values. So if this is x and y, my domain is going to be 6, my x value, and my range is going to be 5. If you have a list of multiple points, you would list all of the x values and all of the y values. What is the slope of a line that's parallel to y equals 4x minus 2? Well, parallel lines have the same slope. So I just have to find the slope of this line, and I can use the same one for any parallel line. The slope is right here, so the slope of a line parallel would also be 4. Now, perpendicular lines have a negative reciprocal slope. So that means I take 4 and I make it negative, and then I make it the reciprocal, which means I flip the fraction, or whatever would multiply by this to give me 1. That's the actual definition of a reciprocal. So, but if I think about flipping the fraction, I could think of negative 4 being over 1. So if I flip it, it's 1 over 4. Now, if, again, just to this is a reciprocal to this, because if I multiply them together, I will get 1, right? On the top, I'll have a positive 4, and on the bottom, I'll have a positive 4, and that equals 1. So these are reciprocals of each other. So we started with this, took the negative, and then took the reciprocal. This is the answer then to my perpendicular line slope. It would be negative 1/4. All right, g of negative 2, given that this is our g function. So again, this is function notation. I read this as g of negative 2, given that g of x is 8 minus 4x. So this is really just the x value that I want to plug in and find out what the answer is. So that's where I talk about my domain, or my x values are my inputs. So I'm going to input negative 2 into the equation to solve for what the function is, or the output. So negative 4 times negative 2, that gives me a positive 8. So 8 plus 8 is 16. So my output is 16. You could say that that's the answer. You could write it as g of negative 2 is equal to 16. Okay, here's a different way to write functions. This is just the arrow notation. It means that the function, when you put in x, will be 6 plus 2x squared. It's the same sort of thing. If I want to find f of negative 4, I'm just going to put negative 4 in for my x. So I have 6 plus 2 times negative 4, and then I square it. Negative 4 squared will be a positive 16. 2 times 16 is 32. So 6 plus 32 is 38. Again, I would probably write it as f of negative 4 equals 38. On to parabolas. Find the vertex of the graph of f of x is equal to negative 2x squared plus 4x. Then draw the graph. When you see this x squared, you know that we're no longer working with linear or lines. We are working with quadratics, and a quadratic graphs as a parabola. Remember, a parabola is like a U shape, and it can be upside right or upside down. The best way to find these is just to make an XY chart. Remember to choose some positive values, some negative values, and don't choose them too far apart. We have a grid that only goes 10 and negative 10, so don't choose anything bigger than that. To find the vertex, we have a little formula for it, and it actually comes from the quadratic equation, which we haven't covered very well. But our vertex, our x value for the vertex, is negative b over 2a. So our standard equation would be like this. A is the number in front of the x squared. B is the number in front of x. If your equation is written down differently, where it maybe has 8 plus 4x minus 2x squared, you're going to need to remember to rearrange it in descending power order, because your a always comes from your x squared, not necessarily the first thing written in the equation. In this case, it is written in descending power order, so a will be the negative 2, and b will be 4. And I don't have a c in this case. It's not in my vertex equation, so that's fine. Negative b is going to be negative 4, and then 2 times negative 2. So I have negative 4 over negative 4, which is just 1. So the value of my vertex is 1 for x. How do I find out what y is? Well, I have to plug it into my equation. I'm going to erase these little things so I can see my equation better. So I'm going to plug in 1 for x. I have negative 2 times 1 squared plus 4 times 1. So 1 squared is 1 times negative 2. 4 times 1 is just 4. So 4 plus a negative 2 is giving me a positive 2. So my vertex is 1, 2. The point 1, 2. So there's my vertex. Now, if I want to draw the graph, I need to plot a few more points. If this is my vertex, I might want to do 1 or 2 points on the left side and 1 or 2 points on the right side. So I'm going to choose 0, and then I'm going to skip to -2. On the other side, I'll choose 2 and 3. If I plug 0 in, I get 0 plus 0. Look at that. It's going to be at 0, 0. How about -2? -2 times -2 squared plus 4 times -2. -2 squared is a +4. So a +4 times a -2 will give me -8. And this one over here is going to give me 4 times a -2. That's also a -8. So I get -16 when I plug in -2. So it's going to be off the graph down here. So now I know it's going to be a narrow curve because I dropped way down. Let's plug in a +2. 4 times 2 is 8. 2 squared is 4 times -2 is -8. So this ends up being 0. 2, 0. And then the last one we'll plug in 3. 3 squared is 9 times -2 is -18. 4 times 3 is 12. So -18 plus 12, that gives me just a -6. So I can connect all these points. And there is my graph. The next one is find the vertex and the greatest value for this graph right here. Again, my vertex equation, or my x value of my vertex, is -b over 2a. This is my b value, and I'm going to take the negative with it. So my b value is -6. If I have a negative -6, it's going to be positive. And my a value is what's in front of the x squared. Don't say that there's nothing there. If there was nothing, you'd be multiplying by 0. There's actually an unspoken 1. So 2 times 1. So again, my top is a +6. My bottom is 2. When I divide this out, I get 3. That's my x value. I still have to find what the y value is. And I find that by plugging in 3 for my x. So 3 squared is 9. -6 times 3 is -18, and then another -18. -18 and -18 is a -36. 9 minus 36 will be -27. What's the greatest value for this graph? Well, we have to know a little bit about the graph. The graph has a positive x squared. The one that we just graphed was a negative x squared. And when it was negative, it pointed down. So when it's a positive x squared, it's going to open up. If it opens up, where's our vertex? Our vertex is at the bottom. So our vertex is our lowest value. What is our greatest value then? These keep going in both directions. A little bit of a trick question. The greatest value is infinity. It goes up forever. And so this is the infinity symbol. So this question was probably meant to ask what's the lowest value, and so our vertex would also be our lowest value. Our lowest value would be the y, or the -27. So our lowest value would be negative 27. All right, the constant of variation, if y varies directly as x, y is 45 and x is 15. Okay, direct variation is going to be where the constant is a fraction. And we just put the y over the x, so we say 45 over 15. If you can reduce it, go ahead. So 45 divided by 15 is 3. That is our constant of variation. We could use that if they said, okay, what is x when y is 11? What is x when y is 11? Well, we could use our proportions. We could say 45 over 15 equals 11 over x. Or we could know that we've already solved 45 over 15. That's 3. So 3 equals 11 over x. In this case, we need to multiply the x on both sides. So 3x is equal to 11. Then we would divide by 3, and x would be 11 thirds. Find the missing value if 50 and 6.5 and a blank, so we don't know our x, and 25 are ordered pairs of the same inverse variation. So inverse variation, we don't make them fractions, we multiply them together. X times y equals x times y, or you could say that x times y equals the k. So I'm going to say 50 times 6.5 is equal to what times 25? If I divide by 25 right here, I can do this mentally. 50 divided by 25 is going to leave me 2 on the top. 2 times 6.5 is, well, 2 times 6 would be 12, and 2 times 0.5 would be 1, so 12 plus 1 would be 13. So x is equal to 13. Again, you could put that into a calculator if you need to.